Hello, my name is Antara Nimkar, roll number 21. Today, our topic for the IE presentation is NoSQL, that is non structured query language. So, what is NoSQL? Not only SQL, which is used to describe databases that provide storage and retrieval of data using models. Let's look at the overview of NoSQL. First is diverse data models. NoSQL databases offer various data models to cater to different types of data and use cases. Some common data model includes document store, key value store, common family store, graph databases. Second is scalability. No SQL databases are designed to scale horizontally, meaning that they can handle large volumes of data by distributing it across multiple nodes in a cluster. Third, flexibility and schema-less design. NoSQL databases typically offer a flexible schema or schema-less design, allowing developers to store and retrieve data without predefined schemas. Next, high availability and fault tolerance. Many NoSQL databases are designed with inbuilt mechanism for high availability and fault tolerance. They often support features like data replication, automatic failure, and data partitioning to ensure data availability and reliability. Next is performance optimization. No SQL databases are optimized for specific use cases and performance requirement. They often offer features such as in-memory caching, replication, and specified indexing to improve data access and query performance. Next, we'll look at the generations. First generation, 1960s to 1970s. Here, the network databases were there, uh, where there was the limited flexibility, that they were rigid in structure and required extensive planning for data organization. The second generation was from 1980s to 2000, where relational databases were invented, that is Oracle, IBM, and Microsoft SQL Server. Then there was SQL became the universal language for querying and managing relational databases. Acid properties like atomicity, consistency, isolation, and durability were ensured for data integrity. Then normalization. Normalization was used to reduce the redundancy and improve data integrity. The third generation was from 2000 to present, where NoSQL and new SQL databases were introduced, which emerged and combined the benefits of SQL and NoSQL, which provided scalability and flexibility. They were suitable for handling big data and distributed systems. Now, I'll tell you about the history of NoSQL databases. In early 20s, Google's big data table was a distributed storage system for managing structured data. Then in mid 2000, Amazon DynamoDB, Apache CouchDB were there. Then in late 2000, Apache Cassandra, MongoDB were released. MongoDB was widespread adoption as a document-oriented database. It offered a flexible schema, high performance, and horizontal scalability. Then we'll talk about the present and future. That is the diverse landscape. The NoSQL ecosystem has grown significantly with a wide range of databases catering to various use cases, which includes Apache HBase for column-based family stores. Next is hybrid solutions. Some databases blur the line between NoSQL and SQL, offering the flexibility of NoSQL with the familiarity of SQL. These hybrid solutions, sometimes referred to as new SQL databases, aim to provide the best of both sides.
My name is Aryan Nimkar, roll number 22. There are four types of NoSQL databases. First is key value stores, document databases, column family stores, and graph databases. Key value stores. Simple data model, high performance. Stores data as a key value pairs, fast retrievals and writes. Document databases, simple schema, flexible structure for organizing and storing data. JSON or XML file, popular data interchange formats, use cases ideal for content management systems and real-time analytics. Column family databases, column-oriented data stored in column groups rather than rows, distributed horizontal scaling across multiple nodes, high performance, efficient for read and write intensive workloads. Graph databases, relationships, data structure focused on connections between entities, use cases well suited for social media networks and fraud detection. Characteristics of NoSQL databases: scalability, flexibility, distribution. Scalability and performance: horizontal scaling can be done to handle an increase in load by adding more servers. High performance can be used to efficient data retrieval. Fault tolerance to ensure minimum downtime.
Now I am going to discuss about the difference between RDBMS and NoSQL. RDBMS is the relational data type, whereas NoSQL is non-relational data type. RDBMS contains table which contains columns and rows, whereas NoSQL has different data types such as key value, document, column family, and graph. RDBMS follows a structure schema where it is predefined before entering the data into the table, whereas NoSQL has a flexible schema which adapts itself according to the entered data. That's why NoSQL is beneficial in the unstructured data. RDBMS scalability is vertical, which means if you want to increase the capacity of the database, you need to increase more RAM or CPU or the storage. Whereas NoSQL follows distributed hardware system, means you can increase the number of devices which will integrate the data together to perform the results. Therefore, NoSQL gives better result in the performance. Also, the cost of NoSQL is less in the scalability compared to RDBMS. Complex queries are processed through RDBMS. Transactions are also integral part, which allows banking systems, accounting systems, traditional business applications to smoothly perform transactions. Even using transaction backup data or the catalog or a time lock can be created. Whereas NoSQL follows simple structure, focuses more on big data analysis or a real-time application such as social media or likes, comments, etc. RDBMS follows ACID properties, that is atomacy, consistency, isolation and durability, whereas NoSQL follows BASC, that is basically available, soft states, eventually consistent. NoSQL RDBMS gives a high level data integrity. Enforced schema and relational constraints are handled efficiently, whereas NoSQL focuses on data modeling and adapting quick changes to the data. Examples of RDBMS can be web application, mobile applications, data mart, enterprises. NoSQL examples are real-time applications such as gaming, social media, IoT. Also, the RDBMS applications at this NoSQL is in at the developing stage. Thank you.
Hello friend, my name is Aditya Oja. Let's start the topic. The benefits of NoSQL database: flexible schema, scalability, high performance, fault tolerance, and support for big data. Other benefits also: ease of development, cost effective schema evaluation, support for unstructured data, and use case flexibility. Also, there is a new topic, that is NoSQL business drives, that is a business across industries for specific advantages. There are some key points for this: real-time analytics, scalability, improved customer experience, cost saving, and high availability. Other some keys are other Other keys are the personalized marketing, IoT data processing, content management, e-commerce platforms, social media, and gaming. Thank you.
Hello everyone, I'm Shreya Ojha, roll number 24. Let's explore NoSQL case study and discuss the concept of keeping components simple to promote reuse. NoSQL case study MongoDB at Airbnb. Airbnb, the popular online marketplace for lodging and travel experiences, uses MongoDB as one of its primary NoSQL databases. MongoDB's flexible schema and scalability features have proven beneficial for Airbnb's diverse data requirements. Some of the challenges that it faces is diverse data types. That is, Airbnb deals with a wide range of data types from user profiles and booking information to property details and reviews. Scalability challenges. As one of the world's largest online travel platforms, Airbnb needs database solution that could scale horizontally to handle increased data volumes and traffic. The solution it provides is flexible schema. MongoDB's document-based model allowed Airbnb to handle diverse data types without being constrained by fixed schema. This flexibility made it easier to adapt and changing business requirements. Horizontal scaling. MongoDB's sharding capabilities enabled Airbnb to distribute its data across multiple servers, supporting the platform's scalability needs. Benefits. Developer productivity. MongoDB's easy use of handling various data structures contributed to its improved developer productivity. Scalability. With MongoDB, Airbnb can handle large amounts of data and traffic, ensuring a seamless experience for users. Keeping components simple to promote reuse. The importance of component reusability includes scalability. Reusable components simplify development and maintenance, making it easier to scale applications. Consistency. Reusing components ensures consistency in design and functionality across the application. Efficiency. Developers can save time, effort by leveraging existing components rather than inventing the wheel. Best practices for keeping components simple. Single responsibility principle. That is, each component should have a single responsibility, making it easier to understand, test, and reuse. Clear interfaces. Components should expose clear and well-defined interfaces.
System design is process of defining architecture, components, module, interfaces and data for a system to satisfy specific requirement. It is basically generating a blueprint of an idea. Objective of the system design. First one, practicality. It must target certain set of audience. Second one, accuracy. Fill nearly all the requirement of your idea. Third one, completeness. Meet all the user's needs. Fourth one, efficient. Utilize all your resources. It must enhance your throughput and reduce your response time. Fifth one, reliability. It must be near to the failure free environment. Sixth one, optimize. It must be optimized in terms of the time and space complexity. Seventh one, scalable. It must be adaptable as per the time change. It must be flexible so it may keep on changing for the further needs. Now we are going to learn about monolithic architecture. Before learning it, we must get some basic terms information. First one is user interface, which is the main front end that the users see. Business logic is the code behind where the main code is written. It if you are calculating the numbers in user interface, you will going to see for the spaces for the input devices. At business logic, the actual code is written for the submission of the two number, and at the end comes your database where the actual data is stored. Now talking about monolithic architecture, it is a singular large computing network written one code base that couples all your business together means one single code is written for your all your requirement. What are its benefits? It's basically simple, it is easy to deploy, it follow a particular procedure that is known as this streamlined development. It's load fast because it's in a singular file. Uh, Now there are some cons of it. It is less flexible. If you want to make changes, you have to go to the whole code. It's not scalable. The actual code is interdependent on this one file only. If this line failures, this logic fails, the entire system is shut down. Example of it is you created a to-do list or a calculator. The whole code is written in this one file, so everything is sum up in one thing, which is known as a monolithic architecture. Other example is your microprocessor, and in order to code it, we can use the assembly language. This is a part of monolithic architecture. Now we will going to learn about the microservices architecture. It is basically application that is developed as a collection of set of the services. Each service is going to have its own business logic, as well as it's going to have its own databases. This it's a broader aspect of the monolithic architecture. Monolithic architecture is one, whereas microservices contain different type of the monolithic that are joined together using the API. Now its benefit, it's very scalable. If you want to work upon one singular part, you can divide the tasks into the different part and you can work upon it. If you want to make any changes, so it's very flexible, so you have to do changes in that particular part. It has become independent development. If one part is failure, the other part going to be run, so you can make changes or you can set up the bugs and can carry forward with the rest of the part. It's work on the cross functional technology. You can use different type of technologies at the same time. This is benefit of the microservices. Has benefits come, there are some big cons of it too. First, you have to make a proper structure, how the thing is going to be retrieved, from which of the files or which of the APIs is going to link, where output is going to be stored, where it's going to be take the input in the betweens. So it's very complex design you have to make. It's very difficult to test because you have to test each and part individually. Uh, Has there are various type of the services available, various type of different logic, to security aspect become the more concern over it. Now talk about it. One example is of cab booking app, where being a user, I want to see the cab prices, I want to book the cab, I want to see where my cab has been. This is one part of for the user. On the other end, in the same app, the driver is seeing the where is the customer, the customer ID is going to, he is knowing its pickup location as well as the drop location. So there is a different set of coding done for the driver part also. The third comes the GPS location, how they are using the maps, Google's map API in the between. So there has been code done for the each and individual part on a different level. This is how where microservices architecture plays an important role over here. Thank you.
In this presentation, we are going to learn optimizing performance by using the power of RAM, SSD, and disk. So, in the introduction part, we are going to understand the role of RAM, SSD, and disk in optimizing system performance. Is it crucial for maximizing efficiency and speed? This presentation will explore the benefits of each component and how they can be harnessed to enhance overall performance. So let's move to the first one, harnessing the power of RAM. RAM plays a pivotal role in system performance, acting as a high-speed temporary storage for data that the CPU needs to access quickly. By optimizing RAM usage and employing efficient memory management techniques, overall system responsiveness and multitasking capabilities can be significantly improved. So let's move to the second one, that is the speed of SSD. The advent of SSD technology has revolutionized data storage by providing faster read and write speeds compared to traditional hard drives. By utilizing SSDs for operating system and frequently accessed data storage, significant performance gains can be achieved, resulting in reduced boot times and faster application loading. This is how the leveraging the speed of SSD will work. So let's move to the third one, that is optimizing disk performance. While disk storage may not match the speed of RAM or SSDs, optimizing disk performance through defragmentation,
Proper file organization and utilizing high-speed interfaces such as NVMe can enhance data access speed. Understanding the role of disk storage and employing optimization strategies is essential for achieving a well-rounded performance improvement. So let's end this presentation by giving a conclusion. The conclusion is very simple that the harnessing the combined power of RAM, SSD and disk is essential for achieving optimal system performance. By understanding the unique strengths of each component and implementing effective utilization and optimization strategies to each of them, user can experience significant improvements in speed, responsiveness and overall efficiency.
Now we are going to discuss about acid and base. Acid and base both are transaction models in NoSQL databases. ACID stands for atomicity, consistency, isolation, durability. Now, atomicity means traditional transaction model used in relational databases. Consistency means provides strong consistency guarantees. Isolation ensures all transactions are completed successfully or rolled back entirely if any part falls. Durability means suitable for application requiring data integrity and strict consistency. Now we'll talk about BASE, which stands for basically available, soft state, eventually consistent. Now basically available, it means transactions model used. This transaction model is used in so many NoSQL databases. Soft state emphasizes availability and partition at tolerance, strict consistency. It is eventually consistent where data may be inconsistent temporarily but resolves over time. Ideal for highly distributed systems and applications prioritizing availability over consistency. Moving to the next slide, we'll talk about what the acid versus base comparison. ACID stands for atomicity, consistency, isolation, durability. Now, atomicity. Atomicity is where transactions are all or nothing. Either all operations succeed or the entire transaction is rolled back. Consistency, where the database remains in a consistent state before and after the transaction. Isolation, transactions occur independently of each other, ensuring they don't interfere with one another. Durability, once a transaction is committed, changes are permanent and won't be lost, even in the event of system failure. Base, which means basically available, soft state, eventually. Now, what does basically available means? It guarantees availability even in the face of network partitions or failures. Soft state. Soft state allows for temporary inconsistency in distribution system. Eventually consistent. Over the time, the system will converge to a consistent state, though it may experience temporary inconsistency. Now let's move on to the third slide. Decision factors. Which of the transactions method we should use, acid or base? Use case. Choose acid for applications requiring strict consistency and data integrity. Choose base for highly scalable distributed systems prioritizing availability and partition tolerance. What are the trade-offs? Acid ensures data consistency but can impact scalability. Base sacrifices immediate consistency for increased availability and scalability.
Good morning, everyone. My name is Sujal Pal. So I will continue with the minimizing downtime with database sharding, and in this we will understand how database sharding and Brewer's cap theorem can minimize downtime. So let's further begin. So first of all, let introduce about the database sharding. So what does database sharding do? It improves the efficient data distribution. Database sharding allows distributing data across multiple servers for efficient. Database sharding allows distributing for data across multiple servers for efficient handling. Second was the improve performance. Each shard reduces the load on individual servers, improving overall performance. And third one is enhance scalability. As data grows, new shards can be added, ensuring the system remains scalable. So the next slide represents the explanation of Brewer's cap theorem. So in this, the Brewer's caption explains the three things in which the two of them are available to follows: consistency, availability, and partition tolerance. Now let's see what is consistency. As data remains consistent all over the nodes in a system. And so the second one is availability. The system is available and responsive under normal conditions at any cost it takes. Partition tolerance: the system can function despite network partitioning and communication failures. It means that the system can work if the can work continue if the partitions or communication fails. So now understanding database sharding trades off data consistency, and it means that trades off between the consistency and able to minimize the downtime. And the second one is upskilling challenges, trades off related to partition tolerance and system scalability. Now let's talk about the benefits of database sharding in minimizing downtime. First one is high availability, improve systems availability with distributed across shards. Second one is reduce impact, minimize impact of individual server failures on the entire system. And the third one is enhanced recovery, rapid recovery with parallel data retrieval, processing multiple shards. So let's talk about the strategies for implementing database sharding. First one is data security, implementing strong security measures across shard distribution. Second one is maintenance effort, strategies to minimize downtime during regular maintenance activities. And third one is scalable infrastructure, building a scalable infrastructure for seamless sharding expansion. Let's talk about what are the challenges and considerations in database sharding. First one is network complexity, managing internode communication and synchronization challenges. Second one is data migration, challenges related to migrating and redistributing across different data shards. And third one is performance optimization, ensuring the consistent performance and alignment with business objectives. Thank you all. So we have talked about the different sharding techniques, how to implement it, and how to prevent it from different types of issues, etc. So thank you.
Hello to all of you. I am Adarsh Pandey and my roll number is 29. So I am going to explain about NoSQL architecture. The first one, NoSQL offers schemaless design. One of the key features of many NoSQL databases is the schemaless or schema flexible design. Unlike traditional relational databases which enforce a fixed schema requiring predefined tables, columns and data types, NoSQL databases offer more flexibility in how data is structured and stored. The second one is distributed architecture. Distributed architecture is a design approach where components of a software are spread across multiple computers, often referred as the nodes or servers, which communicate, coordinate with each other to achieve a common goal. In the context of database, distributed architecture is crucial for achieving scalability, fault tolerance, and high availability. And the third one is CAP theorem. NoSQL databases often consider the CAP theorem when designing their systems. The CAP theorem, proposed by computer scientist Eric Brewer, states that distributed data store it is impossible to simultaneously achieve all the three following guarantees. The first one is consistency. The second one is availability, that every request receives a response without the guarantee that it contains the most recent write. And the third one is partition. According to CAP theorem, a distributed system can only guarantee 2 out of 3 properties, that is consistency, availability, and the partition tolerance. NoSQL databases typically make trade-offs between these 3 properties based on the specific requirements of the application. So now we'll move further on NoSQL data architecture patterns and its types. NoSQL databases offer various data architecture patterns to address different data storage and retrieval needs. Here there are three types of NoSQL data architecture patterns. The first one is key stores. In key value stores, data is stored in schemaless fashion where each item is a key valued pair. They are highly performant for simple retrieval and storage operations. Examples include Redis, Amazon DynamoDB, RAC, etc. The second one is column oriented stores. Column oriented stores organize data by columns rather than rows. Data for each column is stored together, allowing for efficient querying and retrieval of specific columns. These databases are well suited for analytical workloads and applications requiring heavy read operations. Examples include Apache Cassandra, Apache HBase, etc. The third one is graph stores. Graph stores are designed to represent and store data in terms of entities and relationship between them. They excel in representing and querying complex relationship between data points. Graph databases are highly suitable for social networks, recommendation engines, fraud detection, and network analysis. Examples include Neo4j, Amazon Neptune, Janus Graph, etc. Each type of NoSQL data stores offers different trade-offs in terms of scalability, flexibility, and performance. The choice of architecture patterns depends on specific requirements of the application and the nature of the data being stored and queried. Thank you.
Now we are going to discuss about analyzing NoSQL databases on the basis of cap theorem versus acid theorem. As the introduction, we will just get an overview of NoSQL databases. An overview of NoSQL databases and trade-off between cap theorem and acid theorem properties. We will explore implications of this principle on database design and performance. Cap theorem. Understanding the consistency, availability, and partition tolerance trade-offs in NoSQL databases, we will delve into implications of choosing one over the another. Acid properties. Acid properties. In this, exploring the atomicity, consistency, isolation, and durability principles in database transactions, we will analyze how NoSQL databases implement these properties. Concluding this, we will summarize the key takeaways of them. Thank you.